Welcome back everybody to the next part in this tutorial. This one is all about the animation tree, which is a complete beast of its own. It's a very powerful tool in Unreal, and there's a lot to go over, so let's start just by maybe opening up the medium tank and having a look at some of the animation trees that are being used inside of, or for the medium tank specifically. So if we go over to the medium tank package and we go into the anim subfolder, you'll see 3 different animation trees that already exist, and 2 of them are for the antennas to the left and right. If you remember the first video, I kind of briefly went over the 2-bone system, which took care of that. Let me just open up one of them, and you can kind of see what it does. Hopefully you can see it in the video. So it's basically one single node applied to the child bone, and that basically gives it a swing. So this node, the specific cantilever beam node, it basically acts as, or it applies momentum every time you move, which is a pretty cool system. Really useful for antennas and moving objects, secondary objects on your vehicle. That's not really a big one. That's pretty simple. This is as simple as it gets for an animation tree. Before I open this is going to be a really big network. It might look very confusing, but really it's the same things repeated over and over again, specifically because there are so many wheels on the medium tank, and each wheel has a control of its own. So let's open it up and let's see what's actually in here. So if I zoom out, there's a ton of stuff in here. Okay, let's start by exploring what kind of components you have in the animation tree. So we can have multiple networks in here, such as one's controlling the animation output, one's controlling the blend shape or morph target outputs, and then you also have custom outputs for each bone in your rig. So let's, before I go into the tank, actually I'll come back to the characters afterwards. Let's start with the medium tank. So in here we have all of the green ones are for custom bones in the vehicle rig, in the skeletal mesh. And then you have the blue ones, which are for the morph targets, and then the pink ones would be, or the orange ones would be for animations. So this one is mostly, or all vehicles really are mostly just the green skeletal mesh custom bone outputs. So we have a number of things in here, such as control outputs for the turret. There's 3 different ones. There's one that controls the left and right rotation. Let me turn my, okay. So there's some that control the left and right turning of the turret itself. Then you have the ones that control the up and down, the pitch of the barrel. And finally you have the recoil component. It's kind of hard to see, or maybe it's not, but yeah, it's a very simple setup for the turret itself, and we'll go over that in a bit. Basically what I'm going to do is I'm going to copy each of these components and just paste them into a new one for the super tank, just because it's quicker and easier to do it this way rather than having to right click and adding them individually. So all of this stuff, everything here, all of these green ones, not the blend shapes, so all of these are all for the wheels. So as mentioned, the medium tank has 14 wheels in the bottom and then 4 more wheels on the top, the ones that are anchored and they don't really move. So that's why you have so many of these, and it's basically a 2-node network, one that controls the wheels So the up and down movement of the wheel. It also has various wheel components that are used natively in the code, so we don't ever have to worry about programming these. These can be set up directly in here, such as which direction do we want the wheels to spin in, what is the steering angle. We could also give it an offset of the suspension if we wanted to, so maybe we want it to be up here, or maybe we want it to be down, further down. Yeah, this is basically our wheel controller. Handles everything that the code really needs to take care of the wheel. Then we have let me show you one thing. I'm just going to disable this node by switching the blend output to 0, so it's not affecting anything. If I go back to the wheel and then I try to offset it now, you'll notice that the tank track didn't move along with it. That's because that's what this node does. So bringing it back down. What this node does is it's basically the equivalent of a position constraint node inside of 3D Studio Max, or not a node, but a position constraint from one object to another. So basically, what we're doing is we're adding, or we're taking the position information of the wheel, which is, so we have the translation of the bone, of the wheel bone. So we just type in the name of the wheel bone in here, and then we tell this node to use that specific bone. And so what this will do is it will basically attach whatever bone this is hooked up to. So this is hooked up to the suspension bone, which is controlling the tank tracks and the little, what do you call it? I don't know if you can see it. Like these parts. So, yeah, this doesn't really do anything, and you don't need to code anything either. This also works as an orientation constraint, but we've disabled that part of it, so it's not adding the rotation, or it's not applying the rotation of the wheel because we don't want it to. We just want to keep the position constraint of the wheel. Yeah, this is basically how we're going to set up our wheels and our tank tracks. So it's just these two nodes replicated multiple times for each wheels, and that's about it. So again, we're going to be copying these two nodes over, and we'll just hook them up. So blend shapes, or morph targets, this is where they are handled. You can have as many input as you want into the morph, but for bones you can only have one. So with blend shapes, so if we go down to mesh, and you can see the morph target set actor, or whatever this is present in the content browser. And that's generated by opening up the skeletal mesh and then going to File and creating a new morph target set for this skeletal mesh. Once you hit OK, you'll basically be given, or this new node will appear in the content browser, and it basically looks exactly like the skeletal mesh previewer, and that's because it is loading the skeletal mesh. But you get this new morph tab, and in here this entire area will be blank, and what you need to do is import each morph target, or if you're using FBX, you can import the blend shapes along with the FBX. But what you have to do when you're exporting out your geo is you would enable one blend shape, and you would then export that specific blend shape out with the full rig. So you would have, so the medium tank, for example, has 14 blend shapes. So we ended up having 14 different PSK files that were imported individually, and So we would basically just go import, and it would add one of these every time we imported it. And basically it's just individual controls for each one of them. So let's enable this one. You can kind of see Crumple's front. So basically we would enable one inside of 3D Studio Max, and then export out to FBX or PSK, and then go back and then export out the next one by enabling the next one, and then in the editor we would just import them all in. So this way you can kind of preview all your blend shapes to make sure they're working. So the blend shape system is pretty simple. It is comprised of two different nodes. One is the weighting, or the blender rather. So it basically just has it has like a blending option, and that in the code it'll take care of this part of it by itself. This is usually given a name that the code can then pick up, and we can use that to trigger a standard blend shape output. So what this node will have is the name of these particular blend shapes. Oh, by the way, you'd have to set up these names manually once you import them in, or maybe you don't have to if you're using FBX. I've never used FBX to import blend shapes because we set them up a long time ago with PSK formats. So you basically just take this name, copy it, and then just paste it in here. So this way the animation tree knows which node to or which blend shape to enable whenever this node is triggered. And this node can be triggered, if you remember in the first video I talked about morph target bones, or empty bones that didn't really do anything. They weren't skin weighted to anything, such as the empty turret front right. This particular bone. It's not skin weighted to anything, but it's there to give us a position for the code. So in the code we can say if a bullet or a tank shell or a rocket or whatever hits anywhere near this bone, then trigger this node. And that's how the code sort of knows which one to look for. So yeah, that's basically how blend shapes are set up. You just take all of them and then you plug them into the morph node. So let's before I show you the character animation tree, let's go ahead and set up actually one last thing. So these two nodes, they're damage point nodes. So if you remember in the first video I talked about certain bone names that had the DP underscore naming convention, and that was for anything that could be tore off or destroyed. So that applies also to any bone. So you can set this up in a network, so you can hook up one of these nodes to an existing node. So for example, on the turret control nodes, I may want the turret itself, the main turret mesh, which if we go to the content browser, you can see the skeletal mesh, or the static mesh of it. It's just normally just static mesh of all of the blend shapes enabled, and then collapse down. So I may want this geometry piece to appear anytime the medium tank is destroyed. So to do that, we would just create a new damage node. So you can find that here, UT Scale Control Damage Node. So you can plug this in after the turret output. Then there's a number of parameters in here, like what is the geometry that you want to break apart? Do you only want it to appear on death? Or do you want it to happen when it takes a certain amount of damage? So there's a number of parameters that you can set up in here. And basically what we did in beta 3 and previous versions is we opened up one of the UT3 example vehicles, like the Scorpion tank for example, And let's fully load it. Okay. And in the animation tree, you could see they're doing exactly the same thing. And we just copied their system, their setup. So we basically just copied one of these nodes, and then we would replicate it for all of the other tanks. That's why when they blew up, in Beta 3 at least, huge debris flew everywhere. And you can see that they're doing that for all of their wheels. You can see that they're doing it for the turret, and many different components, including their main chassis, which kind of breaks apart in the end. So you could hook this up into any one of these bones in the final output, and you could get that debris-like thing that you want, if you want it. I mean, we took it out because there were certain crashes that it was causing, and it wasn't like a game crash for the server. It was more of a client-side crash, so it's not as risky, but it's still a problem. And we did want to reduce the crashing, especially mid-game crashes. Those are like one of the most annoying ones. You're knee deep into the battle, and you're fully immersed, and the next thing you know, a vehicle blows up and it crashes your game. It kind of sucks. Okay, so let's go ahead and create a new animation tree for our tank, our super tank. So I'm going to go to the package, and I'm going to right click and click on new anim tree. I'm going to place it in a subgroup called anims, and I'm going to name it ATVH super tank. So we have this new window open, and it's completely blank and empty, and doesn't look like anything. So what we're gonna do is we need to first load up the skeletal mesh so that the animation tree knows which geometry to apply all of this stuff to. So we're going to go to the mesh subgroup. We're going to select the skeletal mesh, and we're going to add a new item to the preview mesh list. Open up the index, and then you will find preview skeletal mesh. So hook that up, and you should now see your tank. That's about it for this main node. So make sure you have the mesh applied in here. Next thing, we are not seeing any of the bones being outputted in the actual node itself. This is the master node, so you don't see any of these bones, which you need to list out. So to add some of these bones in here, we would right click on this master node and click add skeletal control chain, and this will bring up a new dialog box which gives you the option to select whichever bone that you may want to add. We're going to start with adding the turret controls. So the 3 turret bones, which are the yaw, the pitch, and the fire bones. Let's go ahead and add those, and then let's just set them up real quick. So we could individually go in and create new skeletal mesh or skeletal controls for them by going to right-clicking anywhere, going to skeletal control, a single bone, and then you will see UT skeletal control turret constraint. So we could do that individually, or let's just go ahead and copy paste, and then we'll go over the parameters of each of them. So I'm just going to go to the medium tank. I'm going to hold Control and Alt so I could do a drag select, copy all 3 of these, and then paste them in here. So let's move them up. Let's make this bigger. So you're going to see that these nodes already have a number of parameters hooked up to it. There's one for the yaw control, there's one for the pitch, and then there's one for the recoil. So let's go ahead and hook them up to the appropriate ones. So you want to make sure the yaw bone, the one that controls the left and right, goes to turbo rotate. you want to make sure the pitch goes to turret pitch, and then the recoil or the fire bone gets hooked up to the recoil. So both of these nodes are exactly the same nodes. You can find them in scalp control single bone and UT scalp control jerk constraint, and they are the turn constraint nodes that are built into the game, into Unreal Tournament, and basically they just allow us to give us full control of the turning rotation aspect of turrets. So they allow us to create constraints on certain axes. You can even create constraints based off of angles if you wish to. You can create how much of a lag they're going to have when they're turning their turrets, and that's about it. They don't really have anything more than that, but that's okay because we don't really need anything more than that. So for the turret yaw control, we want to make sure that all three of these are enabled, because, or sorry, all the constraint pitch and the constraint roll are enabled, not the constraint yaw, because we want the turret to be able to turn freely in the left and right direction, but we don't want the turret to rotate in this axis or in this axis, but we do want it to turn in this axis. So the pitch is this direction, the roll, constraint roll, is this direction, and the yaw is this direction. So we want to make sure that there's a constraint on the pitch and the roll, and based off of the values inputted here in the minimum and maximum angles, we can make sure that they don't turn at all in those two directions. And for the yaw constraint, we don't want to enable the yaw constraint for this main cylinder, because we want it to be able to go a full 360 degrees in each direction. But maybe your tank is different and you do need some type of a maximum or a minimum angle rotation limit for how much your turret can turn left and right. So in that case, you would want to enable constraint yaw, and then you can set up what the maximum degree is in each direction. So if you do want to preview what the maximum angle might look like, because if you do plug in a value in here, let's say 45 degrees, nothing's going to show up, and that's because this is the maximum input. If we invert this to the minimum input by adding a negative, then it's going to show us how far it'll turn left or in the counterclockwise direction. But obviously this value should not be placed in the maximum value. This is the output in the in the minimum value. So it would be negative 45 and 45 degrees on the maximum. So this way the turret can only turn clockwise 45 degrees and only turn negative 45 in the other direction. But again, like, this doesn't really help you preview it, so if you want to preview it, then swap these values around. So set this to negative 45, and then you'll see what that looks like, just so you can try it out. You can be like, oh, maybe this isn't enough, maybe I need it to go a little bit more, maybe go to negative 55. So you can play around with that until you find a value that works for you. And then once you're happy with it, then you can just say, okay, the new minimum angle has to be negative 55 degrees, so I'm going to put that there. I'm going to set the positive, or the maximum angle, to positive 55. And there you go, that's how you set up a constraint. And this is the same thing with the pitch. That's exactly what we're doing in this node for controlling the up and down. So we have a negative 10 degree going downwards, but then we also have a 25 degree going upwards. So because these are just the maximum constraints, or sorry, the maximum and minimum constraints. You're not going to preview them, or you can't see them, so if you want to preview them, just plug them in to the other input so you can see what that looks like. So plugging 25 in here, you can see how far that goes up. It doesn't really go up that much. Maybe let's go 45 for this one, why not? So I'm going to plug the original value back in, and then I'm going to update this to 45 degrees. Going back to the turret, rotate, I'm going to take away these constraints, and I'm going to disable constraint yaw because I don't want the the turret to constrain in this direction, in this rotation. So going down, you're going to then find the lag degree per second. So this basically controls how fast the turret can turn. So you can decide whatever value works in your case, and that's all you really need to do. You have a separate input for pitch speed, so you can apply a multiplier. So this is basically a multiplier for this value. So whatever this is, you can say maybe I want it to be 45 degrees for the pitch angle, and you could do it this way. But again, we have controls individually for that. I'm going to leave that alone, and I'm going to leave this at 90 degrees per second as the turn rate. Scrolling down a little bit more, I am adding rotation. So I'm adding the rotation of the parent bone, which is the root bone, because when the tank itself turns, I want the turret to inherit that rotation, as well as be able to control its own rotation on top of that. So I'm adding the rotation of the parent. And finally, going down to the controller name, or the controller tab, we have to input a name into the controller name. So this is the controller node, and we want this node to have a specific name that we can call in the code, so that the code knows which node in the animation tree handles all of the rotation for the main cylinder, the turret that goes left and right. So you can plug in whatever you want in here, and in the code you can set up that name. So you can have your own naming convention if you wish to. So going down to the turret pitch, it's exactly the same thing. We have them constrained in all of the different axes because we do want it to constrain in the up and down axis a little bit, or not the up and down axis, but rather the y-axis, which is going to rotate the barrel up and down. So we can set up the maximum and minimum pitch constraints, which I just showed you already. It has its own lag degree per second, and then another one for pitch. This is a little bit funky because the turret constraint, they almost handle like independent controls. So they're more like, don't think of them as you have one controlling one direction and the other controlling the other direction. It's a little bit weird where they're both full-on turrets that can turn in every direction, and sometimes when you inherit the rotation of the parent bone, it doesn't really work too well, especially for the barrels. So I'm going to leave these at the default settings, and I'll get back to them when we're in future videos, and I'll explain what the problem is. You might find yourself turning your tank and your barrel, not that turret itself, but the barrel turns left and right and you don't want it to, and it's really weird. And I think this will help show you what that problem is, and I'll show you how to fix it as well. So I'm going to leave those values as is, and then scrolling down, again we do have the parent bone hooked up as adding the rotation, but like I said, it doesn't really work all of the time. So this part sometimes just does not function, at least for the barrel. I find it works for the turret, but not for the barrel. I don't know, it's a bit weird. So scrolling down some more, again we have a controller name, so this one has the turret pitch as the controller name, and we're going to hook this one up in the code, just like the turret rotate, which is this guy. And finally we have the recoil node. This is a really fun one because you can live preview it just by pressing this check mark every single time. And you have a number of options like how long the recoil process is, start to finish. So let's make it a bit more cartoony, make it really fast. This value here allows you to say how far of a kickback you want. So maybe you want it to go to something ridiculous, something like that. That's nice and cartoony. The frequency is like a multiplier, so I can, if I change it to -1, it's going to shoot forwards. Pretty funny. And likewise, what you could do is you can have a location or a translation effect on the recoil, or you can have a rotation-based recoil. And a rotation-based recoil is what we're using on some of the vehicles, such as the ones with the Gatling guns on top. So they're using a rotation-based recoil instead of a kickback. So you could use that too if you wish to. So it's basically the same exact setup. You have the frequency and the amplitude in each axis, just like you have the amplitude and frequency for the translation. And finally we have a name for this controller name, so we can reference it in the code. And that's about it for the gun controls. And next thing up, we want to add all of the wheels. Last one. Okay. So I've just added the wheel and the suspension bones into the master node. So what I'm going to do is copy the wheel and the constraint nodes from the medium tank, and I'm just going to go ahead and paste them in here. So let's move them in. Let's go ahead and maximize this. So again, what we're going to do is set up these two networks for the wheels and the suspension bones. And they are by no means complicated, they're actually very simple. So if you want to set them up manually, you could do that by finding the, where is it? Where's the wheel? Oh, yeah. Scout control wheel. So this is the node that we're using for all of the wheels. So in here you have I haven't hooked it up yet. Let's hook it up so you can preview it. So you have options like adding an offset, right? So if you want to do that, you can do that. You can't go more than the max displacement, and really we need to make sure we know what the max displacement is, because this tells us how far up the wheel can go, and it's basically related to the suspension. So we want to make sure that we can sort of fine-tune this value. So using these two, this one can be used, the wheel displacement can be used to preview it, and then once you know what that value is, so let's say 35 units is enough of a maximum height displacement for the wheel before it cannot move up anymore. So now I know I can plug that into the max render displacement, which is a limiter, and I'm going to set the wheel displacement back to 0. And similarly to the wheel displacement, you can actually add an offset in the roll, so you can actually spin the wheel. Maybe rig your wheels so that they're all the same rotation. Maybe they have the texture repeating the same way. You may want to offset it. You could offset it this way, so you could give each wheel a certain different angular rotation. We also need to set up the the roll direction of the wheel. So by default, I think it's on X. Yeah. So we need to set it to Y because that's the axis that we want the wheel to spin in. You have the steering angle, which would be the up and down, the Z-axis. So you could simulate that here as well. You can create an offset if you want to. But again, this is a tank, so we don't need to worry about traditional steering controls. But in a car, if you are setting up a car and you want the front wheels or whatever to turn, you basically just leave this to the up and down axis, which by default is set up to Z. And you don't want to add any offset to the steering. So you can also have inverted rolling and steering if that's what you want. It's up to you. We do want to make sure that both the translation and rotation are applied, because if we don't, then what happens is you're limiting certain parts of the wheel, and we don't want to do that. Oops. So make sure both of them are enabled, at least for the wheels. And finally, we just need to input a controller name that we can reference into the code. So I'm just going to update the name of this because this isn't the medium tank, and I'm going to name it to the super tank. So this one is hooked up to the front right wheel, so I just changed the name to front right. And let's hook up the suspension position constraint. Again, what this does is it will hook up to the wheel. Right now it's not, because it cannot find the bone name because this isn't the medium tank. This is right now, because we copied it from the medium tank animation tree, it has the medium tank bone name as well. So we want to change the bone name to B wheel FR. So let's do that. There you go. So now it's hooked up always to, or it's position constraint to the front wheel. So you want to make sure that it's set to other bone space. That way you can define what that other bone is by listing it here. We don't want to apply rotation, because if we do, then the suspension bone is going to spin, and we don't want to do that. We just want to enable translation because we want to follow the wheel up and down, but we don't want it to spin. And you don't need to set up a controller name in here because we're not going to be referencing this in code. You can see it's already working directly in the viewport, so it will always work no matter what. That's about it for the wheels. I'm going to go ahead and copy these two nodes 3 more times, and then we can just hook them up to the different wheels. And make sure to update the controller name. So this one's hooking up to the front left. So go here, change the name to front left, and update the translation name to front left for the suspension bone. So do that to all of them. So the next one is the right rear. This one. So controller name, oops, rear right, and follow the rear right wheel. Now we have the last one. So do the same thing. Rear left. And rear left. So that's pretty much it for the animation tree in terms of setting up the wheel, or setting up the vehicle. We don't need any more. These are basically all of the essential nodes that you need. So you have your turn controls and you have your wheel controls. But that's not all of what this what the animation tree can do, and I'm going to show you an example from the stealth tank, because the stealth tank has a very interesting setup. As you can see from in-game, the stealth tank has 4 individual tank tracks, and they all follow the curve of the road below. So that was a very interesting setup where so you could see like each one of these are for each tank track, and so basically there are 2 wheels for each tank track, one on the back, one on the front, and then there's a bone, a dummy bone that is skin weighted, located near the back wheel, and it's looking at the wheel at the front, and this entire component, this tank track, is skin weighted to that dummy bone. So as soon as the front part of the wheel, which I believe is this one, goes up, oh, that's the wrong wheel, this one. As soon as it goes up, you can see the tank track goes up. So it's a very interesting setup. It's a very interesting setup where we can use a lookout constraint similar to in 3D Studio Max or Maya. So basically, when you're rigging inside of an animation tree, you can use the same mindset and same setup as when you're rigging a vehicle inside of Max or Maya for like production for film, TV, whatever. So there's a lookout constraint node which allows you to do exactly that. You can see it being used on the stealth tank. So it's hooked up to the one after the wheel control. You can set it up to whatever system you want. Ultimately, like, it's really up to your imagination to figure out and problem solve these particular things. They're really not that complicated, and I'm not really a technical artist. I'm not a rigger. I'm more of an artist by itself, and I'm not even a programmer, so if I can figure this stuff out, I'm pretty sure somebody who knows what they're doing can absolutely figure it out. And I mean, this is really a testament to how easy it is to set up systems that can be very complicated, but not feel like they're complicated, because you can visualize them here in a network, and everything just clicks in your head. So, yeah, pretty cool stuff, right? You could do a lot of really interesting stuff directly in the animation tree. Lastly, let's go over the animation tree of the character rig, because that is pretty awesome. And you're not going to see that much controller names or bone-based controls. That's because we're hardly using anything. We have certain things like IK controls for the hands so that they reposition to the gun. I think we also have like a recoil node, so anytime the gun fires, you can kind of see how that works. Pretty cool, right? Yeah, then you have the IK left and right foot controls for aligning to the ground, which we actually disabled it because it's not really a robust setup, because we're just using the UT3 system right now, and we didn't really have time to set up a full IK for the feet. It wasn't really a priority, but really the most powerful component of creating animation trees for characters is the animation input. And if I zoom out, you can see how massive of a network this really is. It is a very powerful blending system, and you can see each one of these dark red nodes, they are separate animations, and they're getting blended together into one singular input. So you can have a number of different things, such as you may want to blend different animation aim positions, right? So you could do that from here directly, which is really, really, really cool. You have things like different states. So when you're walking, falling, I think there's one for climbing a ladder, I think there's one for swimming. Most of the time we're in the walking state, So we could go to run, crouch, and then we have things like idle, walk, run, and then sprint. So pretty cool stuff. And on top of that, we have multiple different animations, like let's say we want to be turning. So this is the state, this is the animation that plays when you're just turning stationary and the character is rotating, your feet move. It's actually just a sideways walk, but it kind of works out. It looks alright. You also have the aimed and the rest pose, so they get blended between. So on top of that, there is a secondary animation on the entire head, and this is the actual pose, but then we added a new animation on top, which basically just has the entire face sort of looking around, and it creates a really nice nice little feel, as if the character's trying to be situationally aware of what's around him. A neat little thing. Otherwise you just get like this static pose, and that looks really boring. So neat little things you could do. Tons of fun to mess around with, and really I can even show you certain things that we never really implemented, but we did implement in the animation tree, such as the sliding mechanic, where you could kind of slide and shoot. That would have been a pretty neat system to implement, but in the end we never really did it. So tons of awesome in here. I recommend you have a look and just go through it, and they'll give you ideas of just what's possible in here. Yeah, cool stuff. So that's animation trees for you. It's a bit more than just looking at what goes into the tank, because really this is all that's necessary for this tank to function. But I wanted to show you just what's possible with animation trees itself. They are a very powerful tool, and you could input animations into the animation tree. So if your tank has multiple animations, maybe it's a mech or a walker, and you can use this as an input to create the movements of the legs. Just as an example. I mean, I'm sure there's other ways as well. You could probably use IK to sort of simulate the walking animations. So there's endless possibilities. It's really up to your imagination to figure out what you need to do and which way you need to go in order to solve a specific problem. There's usually multiple solutions to each problem, so it's really just up to you to figure out which one works best. So that's it. I'm going to wrap this one up. In the next video, we'll go ahead and take a look at the code. Yay! It's really not that complicated. If, like I said, I'm not a programmer, I'm not even a technical artist. But if I can figure it out, you probably can for sure as well. It's the nice thing about Unreal Script is that it doesn't really require too much brain power. It's the least amount of work necessary to code something in game, which is nice for people who can't code, like myself. So yeah, I'm just gonna wrap this up. I will see you in the next one. Thank you very much for watching. I'm sorry this one took a little bit longer to come out. It's because I had microphone troubles, and yeah, I'm glad I could wrap this one up, because this is a really important one, and I wanted to make sure that I could spark some imagination in you to sort of realize the potential of this tool, so you can make something really awesome with it. I'm looking forward to seeing what you guys come up with, and if you do have questions, please post them in the comments. I'll see you in the next one. Thanks for watching.